Welcome to our session, Uplevel Your Data Expertise, Professional Data Engineer and Professional ML Engineer Certification. I'm Doug Kelly, and I now oversee learning offerings for machine learning and AI solutions on Google Cloud. Previously, I worked as an ML engineer and data scientist at Google Cloud and oversaw data science content at Coursera. I now spend my time thinking deeply about industrializing machine learning development on Google Cloud and driving the creation of training to prepare learners such as yourselves for data and machine learning engineering careers. In this session, I would like to start off by discussing two key data and machine learning challenges that enterprises are facing today: the gap between data platform investments and realizing value from them, and the scarcity and corresponding high demand for data and machine learning engineering talent. This will frame our discussion on how Google Cloud is addressing these, both through data and machine learning platform innovations, as well as through our industry-leading professional certifications, the Professional Data Engineer and Professional ML Engineer certifications. I hold both of these certifications and will share my perspective with you on the benefits of these certifications, as well as the recommended learning paths and resources for each. Lastly, I will give you a preview of what's coming next for data and machine learning training from Google Cloud Learning. My goal for this session is that you walk away excited about building data and machine learning solutions on Google Cloud, and you start or level up your learning journey towards certification today. One of the bigger challenges for data teams is turning into a competitive advantage the immense, fast-growing, and fast-moving amount of data that our organizations, our customers, our partners, our ecosystem is creating. According to IDC, 175 zettabytes of data will be created in the next 5 years. 1 zettabyte equaling 1 trillion gigabytes. That's 21 zeros. Our data production has more than 10x'd in the last 8 years. In fact, 90% of the data in the world has been created in just the past 10 years. Yet when it comes to turning data into business outcomes and business value for companies, the situation is quite alarming. Over 2/3 of the data produced is never actually analyzed, and almost 70% of companies say they're unable to realize tangible and measurable value from data. The key takeaway is this: delivering value with analytics and machine learning requires a modern data platform such as Google Cloud. Data engineers are essential to build, operate, and maintain these data platforms to enable business value. And machine learning engineers, in turn, build and deploy machine learning solutions on top of a robust data platform to drive decision-making and the realization of value. Data engineers and ML engineers work closely together on data teams to close the data value gap by tightly integrating data and machine learning infrastructure. In industry, we know that machine learning has had the most business impact by scaling real-time decision-making and personalization. That means we have to act fast. To do so, we need data engineers enabling data processing and analytics speed, and ML engineers to deliver predictions that arrive at the point of action and real time. That's the difference between discovering and preventing fraud, purchases and cart abandonment, and proactive and reactive customer service. Google Cloud is simplifying data analytics and machine learning through each of the platform design pillars outlined on the slide. We deliver serverless analytics, allowing customers to keep development velocity high in their focus purely on analytics versus infrastructure. We offer a comprehensive set of data analytics workloads, from batch and streaming data processing to data warehousing to business intelligence. We provide the services for our customers to operationalize machine learning solutions, from pre-built ML APIs to AutoML to BigQuery ML to custom TensorFlow and PyTorch models. We enable the best open source data technologies to give you flexibility and choice. And we build for enterprise data and machine learning workloads at any scale. Google Cloud is already a recognized industry leader with a purpose-built end-to-end data analytics and machine learning platform to support the entire data team anywhere, on-premise or on Google Cloud. Data engineers are able to leverage services like PubSub, Dataflow, and Data Fusion to ingest, prepare, and transform data at any scale. They can also leverage new data services like Dataplex and Analytics Hub, and market-leading analytics services such as BigQuery and Looker to manage and quickly surface enterprise data sets and insights to the entire organization. Announced at Google I/O this year, Vertex AI is also rolling out as the successor to AI platform for machine learning development. It provides ML engineers with an integrated suite of services to help enable each stage of your ML workflow, from gathering data to feature engineering to building models, and finally deploying and monitoring these models in production. For example, new Vertex MLOps services like pipelines and feature store give ML engineers reusable ML workflows, while Vertex Predictions gives ML engineers a scalable serverless solution to get model predictions into decision-making UIs faster. Depending upon how you define the machine learning market, if you look at platforms like Qwiklabs, Kaggle, Coursera, and LinkedIn, there are only about 300,000 global professional data engineers, data scientists, and ML engineers today. Yet at the same time, there's huge demand for data engineers and ML engineers in the market. According to Coursera market research, in just the past 12 months, there's been over 200,000 job postings requiring data engineering and ML engineering skills. And that demand has been trending upwards. Over the past 3 years, there's been a 91% increase in job postings requiring these skill sets. Many enterprises are still in the early stages of data platform modernization and AI adoption, and are really struggling to find data engineers and ML engineers to make this happen. To bridge the skills gap, Google Cloud Learning has brought some of the best of Google together: its top engineers, its solutions, and expertise in building large-scale data and machine learning systems to produce 2 industry-leading certifications in the job market: the Professional Data Engineer and Professional ML Engineer. These certifications are not just about Google Cloud technologies. In fact, the initial stages of designing each certification are product agnostic. And just like the real-world examinees are expected to know the vast amount of foundational concepts, design patterns, and technology trade-offs that they may encounter in their day-to-day jobs. So how have these certifications been received by learners and recognized in the job market? Think of Google Cloud certifications as valuable tools to validate your learning and help you build your career, get promoted, and earn raises. In a recent survey of Google Cloud certified individuals conducted by an independent third party, we heard some incredible pieces of feedback from learners across the job market on how Google Cloud certifications have enabled and boosted skills for cloud roles. 78% of respondents were more confident when talking about their future opportunities after certification. 82% of respondents felt proud to have a proof point about their skills and abilities when working with recruiters. 83% of respondents told us they felt more marketable. And finally, 85% of respondents just had the boost of confidence that they both wanted and needed to really get themselves out there for cloud opportunities. So in short, if you're asking yourself, what's in it for me? I hope these anecdotal shares and statistics drive home how learners like yourselves have benefited from Google Cloud certifications. Next, let's take a look a little bit more closely at the value propositions for the Professional Data Engineer and ML Engineer certifications. First, let's talk about the Professional Data Engineer certification. A professional data engineer is the enabler of data-driven decision-making by collecting, transforming, and publishing data. This is an intermediate professional certification that requires 3+ years of industry experience and 1+ years designing and managing data solutions on Google Cloud. We offer a data engineering learning path with hands-on practice through Qwiklabs that culminates in a 2-hour multiple choice and multi-select exam to validate your ability to design, build, and operationalize data processing systems. Upon completion, you earn a shareable credential and gain access to Google Cloud Certified Community, swag, and events. So why do I think you should get certified as a Google Cloud Data Engineer? Data engineering is a challenging applied discipline that is best learned through practice. Through following the recommended learning path, you will complete 30 plus hands-on data engineering labs in a sandbox GCP project environment to practice building and deploying data processing solutions. Further, the Google Cloud Data Engineer certification was recently named as the #1 top paid global IT certification according to Global Knowledge Market Research. You will learn some of the most valuable and in-demand enterprise skills in the market and be indispensable to organizations modernizing their data platforms and looking to adopt machine learning. Third, you will learn data engineering best practices from Google, which brought Hadoop and Beam to the world and currently processes over 2.5 exabytes of logs per month on planet-scale compute and network. Through this certification, you will differentiate yourself for career success by learning how to choose the right data storage and processing services, identify the right balance of trade-offs for various data workloads, and practice implementing production-tested data processing design patterns. To prepare you for the exam, we designed a learning path that covers foundational data concepts and data pipeline design patterns, as well as steps you progressively through key data ingestion, storage, and data transformation services on Google Cloud. For aspiring data engineers, the learning path is designed to be completed in about 3.5 months at about 5 hours per week. For existing data engineers, the Coursera Preparation Certificate is still a great place to start to learn Google Cloud Data Services that you can then supplement as needed with additional hands-on practice through quick labs. I recommend the certification to ML engineers as well, and personally started my certification journey here first. Data management and data processing are key foundations of modern production ML pipelines. Now let's discuss the Professional ML Engineer certification. This is a more advanced certification that also recommends 3+ years of industry experience as a data scientist or machine learning engineer, including at least one year designing and managing machine learning solutions on Google Cloud. A professional ML engineer designs, builds, and productionizes ML models to solve business challenges using Google Cloud ML services and knowledge of proven ML models and techniques. So why do I think you should get certified as a Google Cloud ML engineer? The Google Cloud Professional ML Engineer certification is continuously updated by leading Googler and industry subject matter experts to best reflect the ML engineer skill set in the job market. This gives aspiring and current ML engineers the opportunity to validate their expertise in machine learning in Google Cloud against a rigorous practical industry benchmark exam recognized in the job market. Google is a globally recognized leader in AI research and applied machine learning with over a decade of experience productionizing machine learning systems as part of applications serving billions of users per day. Google Cloud is the platform by which Google delivers this pioneering ML research and product solutions to customers. In fact, Google Cloud's AI platform was recognized by Gartner as an industry leader in its 2020 Magic Quadrant for Cloud AI Developer Services. My key takeaways on the ML Engineer certification for you all are this. The Google Cloud Professional ML Engineer certification is a rewarding learning journey for you to build your development skills on an industry-leading data and machine learning platform to both differentiate yourself as well as position yourself for success in the rapidly evolving field of applied machine learning. The learning path is designed to augment your study through a structured progression of role-based curriculum through Google Cloud Fundamentals, through applied machine learning, and up to MLOps content. It's designed to be completed in about 4 months at about 6 hours per week. The content is available on demand through a Coursera professional certificate with additional hands-on practice opportunities available through Quick Labs. For aspiring ML engineers, I have 2 additional tips for you. First, take advantage of $300 in free credits in the Google Cloud free tier on products such as the ML APIs, AutoML, and BigQuery to start building ML applications today. Second, learn socially and publicly. Form a study group to share your learnings and projects with others. GitHub, blogs, or the Google Cloud Learning Forums are a great place to start. I personally like open source contributions to projects, tutorials, and documentation. Take a look at open issues on some of your favorite ML projects like TensorFlow and Google Cloud samples, tagged as Help Wanted or Good First Issue, as an approachable place to dive in. Lastly, I'd like to share with you all what's coming next for Google Cloud data and machine learning training. It's an exciting time to be developing data and machine learning solutions. So far in 2021, Google Cloud's already industry-leading data and machine learning platform has seen its most significant enhancements in the past 2 to 3 years. In the June 2021 Data Summit, Google Cloud engineering teams laid out their vision for the data cloud with new services like Dataplex and Analytics Hub to bring new data management and analytics sharing capabilities to enterprise data teams. Together, along with new integrations between BigQuery and Looker, data engineers can focus on further breaking down organizational data silos to more broadly socialize insights across organizations to enable business value. Furthermore, at Google I/O in May 2021, Google Cloud announced Vertex AI as the successor to AI Platform, a unification of services such as AutoML and custom training for developing ML solutions faster. There are over 20 plus major updates and net new services reaching GA over the next year, particularly related to MLOps, opening up fundamentally new ways to build and deploy ML solutions and incorporate them into decision-making systems to deliver business value. Vertex AI, BigQuery, and Looker, as well as AI industry solutions, empower data scientists or data engineers and ML engineers with new tools to close the data value gap while enhancing development productivity, the ability to scale your workflow and your decision-making with your data, as well as accelerating time to value. My colleagues and I in Cloud Learning Services are hard at work bringing Data Cloud, Vertex AI, and industry solutions content to you through Quick Labs and Coursera. Stay tuned for significant new data and machine learning training rolling out in the second half of this year, as well as a major update to the professional ML engineer certification for Vertex AI in the second half of 2022. Now I'm keen to switch over to the Google Cloud Console to share with you some of the new capabilities of Vertex AI. Welcome to the Vertex AI ML development platform in the Google Cloud Console. To get started, first enable the Vertex service in the API and Services tab. Vertex AI is a platform that contains services for each phase of the ML development lifecycle, from datasets to predictions, enabling you to go from experimentation to production ML workflows to delivering business value faster. The Datasets tab contains a list of all of your datasets in your project with support for image, tabular, text, and video data types. Managed datasets enable you to create a link between your datasets and your models for traceable and reproducible experiments. You also get descriptive statistics on your dataset, as well as the ability to configure automatic or custom data splitting. The Notebooks tab contains new features such as Managed Vertex Notebooks. Vertex Notebooks are interactive Jupyter Lab development environments that enable you to quickly build custom machine learning solutions. They provide support for multiple frameworks, flexible compute, and easy access to accelerators, like GPUs and TPUs. They also have newer, tighter integrations with key Google Cloud data services like cloud storage and BigQuery in a single window. Check out some of the newer integrations with Dataproc as well, which also makes Vertex notebooks a great single window for development of Apache Spark as well. In the training tab, you can also see and create your training pipelines using the same managed dataset for both AutoML and custom training jobs. You can leverage pre-built containers with your model code with frameworks like TensorFlow, scikit-learn, PyTorch, or XGBoost. For maximal flexibility, you can also leverage custom containers as well, leveraging any framework you'd like with any additional dependencies, upload it to artifact registry, and use it for model training, prediction, or as a pipeline step. AutoML is a great way to quickly build highly accurate models with built-in support for standard evaluation metrics, feature attributions, quick model deployment, as well as metadata that covers the model architecture search, as well as the hyperparameters that were searched as well. In the Experiments tab, you can create a managed TensorBoard instance to organize and compare model performance across model runs and data splits. For predictions, you can deploy new endpoints for online predictions or schedule batch jobs for bulk predictions as well. A model can be deployed to multiple endpoints or can serve multiple models on a single endpoint. With multiple models on a single endpoint and traffic splitting capabilities, you now have some new model prediction evaluation capabilities, such as A/B testing. For production ML workflows, the new Vertex pipeline service enables you to automate, monitor, and govern your machine learning systems by orchestrating your tasks in a serverless manner. Clicking into an individual pipeline run, you have a graphical user interface to view and debug each step of your workflow, from dataset creation, model training, evaluation, and deployment. You can expand upon your artifacts to be able to deep dive into individual pipeline runs and their artifacts, such as model evaluation metrics. In this example, you also have a conditional model deployment step, which you can use to ensure that you're only pushing higher performing models to production. This concludes a quick walkthrough of just some of the new features available in Vertex AI. I encourage you to also check out services like data labeling, ML metadata for tracking your development artifacts across your project, as well as the upcoming feature store, which enables you to reuse features across ML use cases. For hands-on practice in a Google Cloud project with some of the features I just introduced, check out the Vertex AI Labs on Quick Labs. A great place to start is the Vertex AI Quick Start, where you will walk through an end-to-end custom training workflow on Vertex AI to train and deploy a TensorFlow model to predict customer lifetime value. To start your data and machine learning engineering learning journeys today, check out our recently launched Google Cloud Skills Boost, our new destination for Google Cloud Learning with over 700 labs and courses. This will be available to you all the entire month of October, free of charge. It's never been a more exciting and productive time to be building data systems and doing applied machine learning. Thank you for learning with us.